And now I'd like to welcome you to today's webinar, Cybersecurity, Then and Now. I'm going to hand things over to our Cybersecurity Product Manager, Mr. Buckchell.
Thank you, Kelly, and hello everyone. Good morning, good afternoon, and good evening, depending on where you're logging in from. I'm Buckchell, the Product Manager for Cybersecurity here at the New Horizons corporate office, and I'd also like to welcome you to today's webinar. This is our 5th out of 10 cybersecurity focused webinars that New Horizons is hosting in the month of October. And if you're not aware, October has been designated as Cybersecurity Awareness Month by the Department of Homeland Security. This is an annual campaign now in its 15th year with a goal of raising awareness about the importance of cybersecurity. National Cybersecurity Awareness Month is a collaborative effort between the U.S. Department of Homeland Security and its public and private partners, including the National Cybersecurity Alliance, to raise awareness about the importance of cybersecurity and individual cyber hygiene. New Horizons Cybersecurity Awareness Month is now in our 3rd year as an annual focus month, and the goal of our webinars, done in conjunction with our industry partners, is to provide you with a better understanding of how to stay safer online with input from subject matter experts to help enhance your organization's cyber resilience and overall cybersecurity posture. You can find a cybersecurity awareness landing page at your local New Horizons website, so you can find by going to newhorizons.com, clicking on Find a Location, and you'll see a Cybersecurity Awareness Month campaigns under promotions, where you can find a full list of upcoming cybersecurity webinars that we have. There's 5 more coming. We've done 5 already. This is the 5th one. You can find the recordings along with free downloadable cybersecurity resources. These 10 cybersecurity webinars that New Horizons is hosting this month cover different aspects about today's ever-evolving cyber threat landscape. Today's webinar, Cybersecurity Then and Now, we're going to discuss how cybersecurity threats continue to evolve and how it's more critical than ever that your cybersecurity defenses meet the requirements of today and those of the future. Our presenter is Chris Kesselberg, a security engineer and instructor with Cloud Harmonics. Cloud Harmonics is a New Horizons partner. Chris, having been on the front line of security for 7 years, has a keen insight in how the landscape has changed. And take it away, Chris.
Hey, thanks for that, Buck. And again, I'd like to thank everybody for jumping on the call with us today. I'm glad to be here and really glad to just have some time to talk about cybersecurity in general. I am very lucky to be able to work in a career field that I love. I actually switched to come here because I like security so much, and both offensive and defensive. As Buck said, I have about 7 years of experience. I work with both blue team and red team scenarios, so I do perform penetration tests, and I do assist in consulting a lot of our end user customers on how they can better not only implement security systems, but what are the things they should look for as they continue to grow as a company. So today's call, what we're going to be walking through is specifically what's changed in the last 5 years, and how do we expect that to kind of give us information for the next 5 years of what's going to happen. We're going to talk about the landscape of security. It's in a constantly evolving state. It's never static. We never get the ability to just say, all right, I think I'm secure enough at this point. That's never something that we can say, and that's okay. It's a reality of the world we live in. So we need to understand how can we effectively provide security to our companies, to our customers' companies, whoever it is that we're interacting with at the end of the day. And there's a lot of implications that go in with that. But what we're going to talk about in this case is we're going to keep it pretty broad. I want to take a look at throughput and growth requirements, how that's affected the requirements for data interpretation or analysis at the network level, and what kind of impact that really means for hardware in your environment, or maybe virtual solutions as well. And then I want to definitely take a look at the Palo Alto Networks security platform. And the reason we work with Palo Alto Networks so often is because they fundamentally approach the problem of security in a different fashion than most organizations out there. A lot of organizations in security today were in networking 10, 15 years ago. Right? Palo Alto didn't exist then. They were a company founded specifically on the principles of providing the best-in-class enterprise-level security, and it shows in their product. So we're going to take a high-level look at the next-generation firewall, the components of App ID, Content ID, User ID, and how that really increases not only our visibility, but ultimately how we can control what occurs in our environments. We also need to talk a little bit about encryption and, of course, decryption as well. This is something that you're going to encounter no matter where you are and whether you think about it or not. Encryption does provide a lot of good things for us. Secure communication streams, right? We get validation of who people are on the internet when we're sending data. There's a lot of great fundamental principles that come out of using encryption, and that's wonderful. But in security, we're all about gaining visibility, and we don't want to limit that visibility in any way. So we're going to take a look at what it really means to have something encrypted, or what it means to have, SSL or TLS on your servers, and then why decryption is actually really important for a lot of what we do in security engineering and analysis in terms of trying to find out what's actually going on in our networks. Then I want to transition over to the endpoint. All right, and we're going to take a look at an attack that occurred last year. It was a pretty prominent ransomware attack that hit a lot of organizations around the globe, both the United States, the Ukrainian government, and it's the WannaCry, WannaCryptor attack. We want to look at what it did, and then ultimately, who were the companies that were successful in preventing these attacks? Why were they successful in that? And we want to see how Palo Alto's solution with their Traps endpoint protection can actually handle some of that for us as well into the future when we see the next big wave of these. So, all right, that's just a little introduction, but I'd like to just go ahead and dive right in here. Now, when I say something like the security landscape has changed, I just want to reiterate that it's never really at a static or non-moving state. It's constantly evolving. We build better mousetraps, we build better security controls, we build better analysis. We have all the information in the world at this point. In 2018, I can give you more data than you would ever be able to do anything with. And that's actually causing problems in a lot of scenarios. In real world scenarios, we have limited resources. I don't have infinite team members. I don't have infinite bodies to come in and do the work at the end of the day. So we have to be able to prioritize effectively what we're going to take care of, because there's always another alert. There's always going to be another compliance audit. There's always something. That never changes. Beyond that, we've got attackers, both. We've got everything from script kiddies. We've got professional criminal organizations. We've got nation state entities. We continue to see year over year that the battle on the internet just grows and grows. In the ransomware attack that we're going to look at, they're using exploits that were stolen from the United States government, right, and then published on the internet. So this is the reality of the world that we live in. Cyber warfare is real. It's not going anywhere. And I know that sounds ominous and scary. It's a reality. That's the world that we live in right now. So beyond that, let's talk about some good things. Let's talk about companies succeeding. Your company's successful year over year. You continue to do well in business. You continue to branch out. Your company's going to grow. You're going to hire more employees, right? Maybe you open another branch office, or maybe You have an idea for a new application. You want to start moving things to a cloud environment or a hybrid environment. All of these things, we have to start processing more data. More users we have, the more applications they're accessing. Our bandwidth is growing year over year, right? 5 years ago, it was really common to go look into a lot of networks and see 1 meg connections. On a corporate, I worked at Fortune 500 companies that had 1 megabit internet connections for their entire headquarters office. Now, I would be very surprised if, you know, a company like that didn't have 1 gig or 10 gig. Right? That's the trend that we continue to see. So with that increase in bandwidth, just the pure amount of data, that puts a tax on our devices that are sitting on our network, that are capturing this data, that are looking at it, that are giving us information about attacks. So we've got to be mindful of what that really means for the size of our networks. Now I have access to devices. I can put them in virtual environments. I have hardware available to me. I can support not just virtual, but cloud, you know, Azure, AWS, Google Cloud. There's all kinds of options. So when we think about this, we've got to give a little bit more consideration into what is the next 5 years of growth going to look like when we start purchasing both, you know, network infrastructure, any kind of IT infrastructure. Right? Sorry, I'm going to take a sip of my drink there. But throughput is a big concern. And it only gets compounded the more data that we put through here. When we add something like encryption or decryption to the mix, or proxying traffic in any way, or, you know, the more analysis you do, that's the challenges that you really see in a lot of security solutions, network solutions, or that are out there. I'm not going to name names. I don't want to badmouth anybody, but when you have a solution and it's adding latency to that traffic, and you keep adding users and you keep growing, right? You can start to see how this idea does not scale over time. Eventually, something's going to break, and that can be catastrophic for any company, right? I've seen, you hear companies or stories about companies. You can go look, and if their internet's down for an hour, they're losing $1 million. That's insane. But that, again, you know, when we get into financial services companies, banks, people that process any kind of transactions, these systems are up 365 days a year. They don't go down. So that's the kind of challenges that we're talking about. And if that's the critical infrastructure that you're trying to sustain, right, that's your revenue gaining infrastructure, you definitely want to be mindful of adding all of this year over year. Eventually, as I said, something's got to give there. So we've got to be mindful of that as we continue to grow. All right. Now, I want to introduce the Palo Alto Network security platform. Now, notice I didn't say just their next generation firewall or their Traps endpoint solution. I said security platform. And that's truly what it is, what they've built. They did start out as a next generation firewall company. They're very, very successful with that because at a base level, their principles where we want to provide enterprise security and we want to engineer a solution from the ground up that has that one focus in mind. So whereas other solutions are adding latency, or I've got to buy multiple different solutions to do different functionalities, Palo Alto's principle on that is we want to do all of that heavy lifting on one device here, and that's the next generation firewall. That's what we're doing here, and we have visibility in a way that we never had before. Right? In a world, even when we talk about things like, I don't know if anybody's familiar with UTM devices, Unified Threat Management, or before that, you know, just looking at a layer 1 to 4 firewall with an access control list. In terms of visibility, what can I see on a network? It's tenfold of what we had 5 years ago, much less, 10, 20. The reality is we can see pretty much everything at this point, right? There's not a whole lot of things that can't be intercepted and seen in any environment. So what does that mean? Well, it means that we need more context to the information that I'm getting. It's no longer effective for my security analysts to go look at alerts and just see IPs coming back at them. Right? I want to know whose computer that is immediately, and I have to go look that up. Maybe I've got to go use the device management system our company uses, or there's a directory, right? And then I want to look at what IP they're going out to access. Okay, well now I've got to go type in domain tools. I've got to go look up this address, see what kind of history they have. Right? And this is me just beginning my process. This is the typical process that I would take if I'm investigating an alert as an analyst. This over time, you have thousands and thousands and thousands of alerts. Again, nobody has enough staff to go through the amount of data that they're getting. So we need that data prioritized. And that's what Palo Alto's visibility gives us. Instead of looking at IPs, we can start looking at App ID, right? What App ID does for us is it gives us a lot more contextual information, right? Now, instead of going to 10.10.10.10, I see that I've got users going to Facebook, they're going to YouTube, they're accessing Office 365. I've got somebody using Putty. I've got somebody using a torrent client to download files for free on the company internet. Right? That is what I mean about contextual information and visibility. That's a lot more information than just a couple of IP addresses that I've got to go research, right? Now, some of these applications, they do tend to try to hide their information through encrypted tunnels, whether it be SSL, TLS, whatever that may be. And that's where we're going to talk about encryption in a couple slides here, but we'll wait to get to that. So our first principle is App ID, and this is our visibility piece. We can then take this information and start using it in our policies. So I could create blacklists, whitelists, I could group these together. We could say, I want to block Facebook as a whole. Maybe I don't want to do that. Maybe I just want to block the ability to post messages on Facebook. Or maybe I don't want to allow users to play Facebook games, but they can browse it. Right? These are some of the options that we start getting into when we have App ID, when we can start controlling these little individual aspects of applications as well, which is really, really cool. The next step is going to be threat prevention, right? And that's called Content ID in the next generation firewall. So Content ID looks at that same application traffic, and now it says, okay, within that Facebook traffic, within that Google Drive traffic, I want to analyze all of these packets and see if there's any viruses, any spyware. I want to see if there's a vulnerability. Maybe we do have an asset protected, but it's still got a vulnerability. If something else were compromised internally, it could be accessed. Well, if I have my next generation firewall and I have these signatures, I can stop that in transit before it does reach my server. That's a reality of the world that we live in, right? Patch management cycles, things being just up to date. People have QA teams. People still have fear from the old Microsoft days. Microsoft burned people. They released patches that broke critical infrastructure, and people still feel bad about that. 20 years later, 10 years later, it's not just one time that it's happened. So I get the complaints. I understand the complaints from infrastructure teams when they say, I can't just blindly release a Microsoft patch, and I don't think you should either. I believe in the cyclical process. I believe in QA and testing things before you go put them into production. It causes a lot less errors, and it causes a lot less stress for everybody involved at the end of the day. Now, beyond that, we've got to still be able to secure assets, right? And so when I start segmenting things based on maybe VLAN in the network, or I could group together, we could say I've got a VLAN for IT ops, I've got a VLAN for the sales department, I've got a VLAN for security servers, for production servers, for dev, right? All of these different options. This is how we start segmenting the network and controlling with policy. So now when I have a segmented network, I can see this vulnerability in transit and I can stop it. I can prevent or at least contain damage if any of my other security controls fail. And that's very powerful. Now, the last key principle here is user ID. And what user ID does is it brings accountability to actions in the environment. Instead of saying, oh, hey, that traffic came from 10.10.10.10. Now I see, oh, hey, that's Jim in accounting. He's going to Facebook right now. Oh, Susie over in IT Ops, she's using Putty to manage a server. Chuck over in HR, he is accessing Office 365. Right? This is the picture being built. So now I have complete control and complete visibility. And the best part is all of this information that we've said we can now see, we can also use this in our policies and control things. So I can create policies for specific users or user groups. And now I can say, all right, maybe the sales team needs access to Facebook posting, but everybody else really only needs access to browse it. And maybe we put some time control restraints around that as well. I don't want to allow anybody access to torrent things on the company internet. Right? That's a waste of bandwidth. So we're just going to block that outright. And I want to maybe control what users' URLs they're visiting. So we want to put some URL filtration. We've got advanced threat detection in the form of wildfire. These are all the things that we can add as in terms of adding to that visibility and threat detection at the end of the day. All right, so I said I was going to talk a little bit about encryption. Now, encryption is, as I stated before, a good thing. In a lot of scenarios, it really does help us, right? It creates secure communication streams. We can use encryption to secure actual assets, and by assets I mean documents, files, of some sort. But there's some caveats to understanding a lot about encryption. Now, first thing is, let's talk about SSL TLS. Just because my server is using SSL or TLS, that does not inherently mean that that server is secure or safe. That is not a one-to-one relationship at all. What it means is that users who communicate with that server, no matter who they are, will have a secure communication stream, and that's been validated. That's all that SSL and TLS really means. Well, why am I saying this? Because we still want to be able to look at the data inside that secure communication stream. There's a lot of reasons for that. One of the most popular is data exfiltration, right? Corporate espionage, again, another nasty reality of the world that we live in. Sales team, disgruntled employee doesn't like the compensation he's getting at company A, so he positions himself to market at company B and says, hey, if you hire me, I'll bring over the client list to company B. Now, just for the record, guys, that's against the law in a lot of cases. You probably sign NDAs or other agreements with your companies. There's been lawsuits about this. You can go watch some of the DEF CON forensic videos and get a couple laughs about some of these instances where they brought in security experts and expert witnesses such as myself to come look at these guys' hard drives and computers after the fact. Just again, an iteration. Everything can be seen at this point, and there's not a whole lot that can't be seen. So on average, most enterprise networks at this point have anywhere from 40% of 60% of their total network traffic is encrypted. So what does that mean if I've been building this conversation about visibility this entire time and I can't look at a huge chunk of it? That's a big issue for me. So what are my options, right? I've got to go to decryption in some form, at least for certain traffic, right? I want to be able to decrypt my users' outbound going traffic unless, it's something like a sensitive information site. Typically, the best practice that we recommend is you decrypt everything except for healthcare, government, and financial services websites. Everything else is game as soon as you signed your acceptable use agreement to work for the company. So that's typically the best practice that we implement in terms of what kind of decryption policy should I have. There's no need for anybody to have that information. We don't want to interrupt the benefits that our users gain from encryption, right? Beyond that, our security teams also need to see the incoming web requests if our company has any kind of a public-facing web presence. Now, the reason that this is important is, again, because all we have is a secure communication stream. So myself, I could be an attacker. I connect to your web server. Guess what? I can still attack it, right? I'm just doing it in a secure communication stream now, if that makes sense. So I've got to be able, as an analyst, as an engineer, I've got to be able to go look inside the packets that are being sent to our web servers, because I want to make sure people aren't attempting things like buffer overflow attacks, SQL injection, any kind of web application penetration testing that we would use. There's types of ways for us to relay individual packets so I can see every single response that comes from your server, right? And a lot of web servers have ways to hide this information, but you go work in a new environment, you get a new job, you get a team that's young, you're going to encounter situations where if maybe in your own environment you've already seen it. So again, we've got to be able to decrypt and look at the incoming and the outgoing. Right? So what are our options in terms of decryption as of today? Well, I can go out and I can purchase a decryption proxy. We would call this a point solution, meaning I go find a vendor that sells decryption proxies and I buy it just for this one purpose, right? And all this box is going to do is sit inside my environment, decrypt traffic. Now, the downside to using a decryption proxy is, again, we're going to go back to that conversation of latency and scaling. So number one, decrypting anything is extremely hardware intensive, RAM and CPU. No matter what you're doing, I still work a lot with cryptocurrency, and I promise you, it's very, very hardware intensive, even in terms of smaller encryption streams, smaller hashing algorithms that are used. No matter what, anytime you're intercepting and man-in-the-middling any session, it's going to increase the hardware that it takes. So what does that mean for us when we talk about throughput, growth, sizing for the future, and thinking about all these things? It means that, again, a decryption proxy is not going to scale effectively into the future. It's not going to work. And the reason for that is because if we logically think about this, my traffic comes in from the internet, it hits my decryption proxy. My decryption proxy then has to decrypt it, and then it sends it to my next generation firewall. Once my next generation firewall figures out what to do with it, it's going to send it back to the decryption proxy, right? And then the decryption proxy is going to re-encrypt it and send it on to our destination. Instead of all of that, I could just size my next generation firewall up higher from the beginning, because in Palo Alto's case, they have specifically used processors that we call FPGAs. Right? Now, an FPGA stands for Field Programmable Gate Array. And I know that sounds really techy and really confusing, so don't stress, because I feel that way as well. What it essentially means is that these processors were written at a very base level, a programmatically defined to do specific jobs. Right? In this case, they're programmatically defined to decrypt traffic. Right? They are programmatically designed to perform analysis, so signature matching, hash matching, regular expression matching at lightning speed, and so we can do all of this functionality still on the same device. I don't have to go buy a solution and try and integrate it and then worry about, how does this work 3 years down the road, 5 years down the road, right? What happens if this company goes under or gets bought out? Right? I'm kind of up the creek at that point. So in this case, we definitely recommend looking at just, again, size up from the beginning, give yourself room for growth, consider things like decryption from the start, and you'll be ahead of the game when you come look at it 3, 5, 7, 10 years down the road. Okay, now I'm going to transition over to talking a little bit about endpoints. And I want to talk specifically about an attack that occurred last year. And this attack was the WannaCry or WannaCryptor attack. And there's two parts of this. The first one was an SMB worm. SMB stands for server message block. Very, very quickly, it's the way that Windows servers communicate with each other, right? What this vulnerability allowed the attackers to do was infiltrate one system and then propagate essentially a backdoor to every other system with the vulnerability in an environment. And it did so silently. Right? At the point in time that this attack occurred, there was a published patch for the vulnerability. So again, we could get down a rabbit hole about patch management and that culture and what we should be focused on. We're not going to do that today, but it is a point of validation that you should, always be working to better that process. So this worm was actually a piece of code that was delivered in the Shadow Brokers leak that happened, I think, 6 months before the attack. And basically, it was published to the internet. We got access to a bunch of CIA and NSA hacking tools that were published, and they're very effective. I still use many of them today in penetration tests. They are still very, very effective. So this SMB worm spreads through the network, and then once it can't anymore, it kicks in the ransomware piece. Right? And the ransomware piece is it downloads a very small executable onto your computer with directions to delete all of your local backups and then encrypt every file on your computer. And then it actually elevates its privileges and reboots so that you can, even after reboot, it's persistent. The ransom note is still there, and they have complete control over your machine. And it's a very, very damaging attack. Just to give you guys an idea, we've talked about decryption. I said I work with cryptocurrency. Your files are getting encrypted with AES 256. Right? So mathematically, with all of the computing power in the world together, it would still take us something like 300 years to brute force one SHA-256 hash, or AES 256. So the reality of us breaking into that and getting any kind of data recovery is slim to none. There is a possibility that we would luck on it by chance, but the reality is that will never happen. The only option for recovery is if an organization like Interpol or the FBI is pretty prominent in these cases, working with Interpol outside of the United States to shut down these servers and obtain the private keys. Right? If they do obtain the private keys and they publish them, the decryption process can occur. You can do a lot of data recovery, but just to give you an idea of that, I know of an enterprise company in Dallas, Texas that got hit by this attack, and they're still trying to figure out the full scope of the damages to this day. So there's the data recovery process is very long and tedious. The real reality is that you don't ever want to deal with this. I promise you, you don't want to deal with ransomware in your network. It is catastrophic, and it's not going to be fun for a long time if something like this happens in your environment. All right, we'll come back to that here in a second. Before that, I want to actually take a look at the trap solution versus this WannaCry attack. Now, traps is Palo Alto Networks' endpoint solution. And what this is, it has been certified by the PCI Council as an antivirus replacement. It is not a traditional signature-based antivirus. It is focused on the success that Palo Alto has had in their wildfire threat detection cloud. They've taken the technology there and they've added other technology to it, and they've made a extremely powerful endpoint security solution. All right. So this trap solution, there's two things that it focuses on. It focuses on blocking exploits, right? So direct exploitation of an endpoint, whether that's me exploiting an application or a hardware, or excuse me, a software vulnerability, something along those lines. And then on the other token, it also blocks against malware, right? So me getting you to click on a link and download a piece of software, or maybe even a phishing link. I get you to click a link and it looks like a safe web server. Well, maybe we want we want to prevent our users from submitting their credentials there. We can do phishing prevention at the firewall level and now at the endpoint level as well. So when we're focused on the exploitation techniques, rather than creating another signature, right, it's much more effective in blocking malicious behavior and attacks. Because here's the reality, guys. If you're not familiar with penetration testing, if you're not familiar with hacking, the exploitation techniques themselves, we don't really come up with a whole lot of new ones, right? They're pretty kind of set in stone. There's about 20 to 30, but there's not a whole lot of new techniques that come out year over year. Whereas there's billions and billions and billions of new malware variants every year. Right, so companies that are still out there trying to block the newest variant, they're again fundamentally approaching the problem the wrong way. You want to look for the behavior. When we look for the behavior, we have a much more effective ratio, and we have a way lower false positive ratio. That's what we're looking for. Effective data, right? Effective information at the end of the day. All right, so let's take a look at what traps can do versus this WannaCry scenario. Now, again, there's an SMB worm previously patched by Microsoft, and they exploit this SMB vulnerability. Once it's on the machine, it's going to attempt to elevate its privileges and elevate itself to user NT/system, depending on what environment you are. When it's elevated to system, it has the attack has more power than the actual user sitting down, and most administrators in a lot of cases. It can create registry keys. It can affect the boot sector of the hard drive, which it does. There's a lot of capabilities, but the real thing that it does is spread its propagation tool, and that's called double pulsar. That double pulsar tool scans the rest of the network, and it propagates that worm to every other host in the network that has that same vulnerability. Which chances are, if you haven't patched it on one, you probably haven't patched it on a lot of machines. All right. Then once it has propagated itself, when it can no longer spread, it kicks in a ransomware process. All right, so we're actually I'm gonna open this up here, and we're gonna talk about all of these as a whole. But we're gonna start backwards. We're gonna go latest to earliest, yeah. All right, so for the malware piece itself, or the ransomware piece itself, this is an executable that actually gets downloaded to your endpoint, right? Separate from the SMB worm. So this executable is a file, it's a binary that we can analyze, right? And that gives us a lot of power. We have a lot of analysis with traps running locally on the endpoint. So the first thing that we're gonna do is we wanna check this local analysis, right? What does this local analysis mean? Well, in the wildfire threat cloud that we submit files from our next generation firewall to, we use machine learning to look at characteristics of files and traits that typically make them malicious, right? And it gives us a rating. A copy of that machine learning algorithm that has been trained over billions of files at this point over the last 5 to 10 years, a copy of that is stored locally with the Traps agent. So it can do local feature analysis, and it's extremely quick. It takes, less than a minute in a lot of cases. It's seconds in most cases to analyze one file. Now, beyond that, it's not going to stop at local analysis. It's also going to do dynamic analysis, which means submit a copy up to the active cloud so that it can do further testing in a wider array of environments, right? To see if it's maybe malicious, not in the scenario that it got downloaded in, but maybe it's malicious for other assets that we have in our environment, and we still want to prevent that. Now, if there's any kind of threat intelligence, in this case there was not, but had there been, we would have detected that. The wildfire threat intelligence that gets pushed by Palo Alto, if you are a wildfire subscriber, you can get any new signature after it's created, gets pushed down within actually up to 60 seconds, I think now. Okay. And then the last portion is a module specifically dedicated to ransomware protection and the behavior of ransomware. Ransomware is very particular in the way that it operates, right? And it follows a pattern. Install itself, delete your backups, encrypt files. Just for the record, there's not very many legitimate programs out there that follow that direct order or any order close to that in terms of being a useful or relevant application. So that's a pretty common behavior pattern that we can look for and analyze in this scenario for detection. So lots of facets just to that ransomware. And again, we want to stop this stuff before we have to deal with remediation and detection and incident response. I want to stop it before it ever does anything. So let's go a step back. When this SMB worm was on the endpoint, right, we actually have modules to prevent the functionality that it causes here. So I said that it gains kernel level privileges. Well, there's a kernel exploitation module. Normal users in your environment never, ever need to elevate to system level authority on a computer, right? We have user accounts and usernames for a reason. We give you permission to what you need to do. So again, a pretty specific behavior that we can look for. Legitimate applications. The only time they might ever need to run a system, unless it's like a security control of some sort, is typically during the installation process. And even then, they don't usually run a system. They usually just run as administrator. So not fully elevated to what we would call the kernel level. And then beyond that, let's say we didn't have the kernel exploit prevention. Another common behavior is child processes. Right? So malware, typically when it is initially downloaded or instantiated on your endpoint, meaning you clicked on it, what it will do is it will hide itself in an existing process like Outlook or Google Chrome, and then it'll spawn malicious child processes off of that. Again, a very specific action we can look for. In this case, that's an exploitation technique called child processes. Most legitimate applications do not do this. If they do, you should reevaluate your development strategies a little bit there. But there are valid reasons for it. It's just that most legitimate applications don't need to do that because they have no problem registering and showing you what they're doing. Right? So this is how Traps is really going to bring us through on preventing 0 days, the next unheard of attack. What's waiting around the corner, a week from now, 2 weeks from now, a month. Right? Again, this is not going to stop. This is not going to go anywhere. This is kind of the future for us here. All right, just taking a look really quickly. I'm not going to spend too much time here. Palo Alto does have a wide range of security controls. These are the next generation firewalls we're looking at here, ranging in size from supporting everything from a SOHO, small office, home office, or branch environment, all the way up to a data center level. I do have a PA220 at my house. I use it here for a lot of testing, policy creation, and validation, and I love it. It's an excellent device. So beyond that, virtual capabilities as well. This is supported in VMware, NSX, and ESXi. It's supported in Citrix, what am I thinking? Nutanix, Acropolis, Hypervisor, KVM, Azure, Google Cloud, AWS. I might be missing one or two in there, but I think I got the majority of them. Pretty much every environment, the major environment for virtualization out there, and ranging in speeds of threat prevention. Again, I don't typically go by this because I assume that if you're going to purchase a network security control, you're going to turn the network security preventions on the device. So we're going from 100 meg all the way up to 10 gig in terms of threat prevention throughput. So that's throughput with all of that analysis: app ID, content ID, user ID. All right. So again, that's something to consider when we think about the future. Beyond that, training. Palo Alto themselves has a huge platform for training. They have a full engineering certification platform, and they have introductory level platforms as well, intermediate certifications, a full platform of getting familiar and becoming familiar with a wider range of products. They've got some really, really cool stuff coming down the pipeline in terms of what they're doing to even more effectively use machine learning to prioritize contextual information from users depending on their habits in the workplace, their routines. So very, very powerful stuff. They're kind of pioneering that. Nobody else is doing that. And these are very powerful devices. They're going to require training. Once you become familiar with it, it's a great platform to work on. So the 3 levels of training, kind of taking a look at that, there is UTD and awareness. UTD stands for Ultimate Test Drive. These are typically about 2 to 4 hour classes that involve just a quick introduction to one of the aspects of the platform, whether it be their CASB solution, Aperture, or importing other threat feeds through something like autofocus. There's a lot of options there. Then we have foundations level training. These are typically 1-day courses where you have the capability to get firsthand with the firewall and jump in here and be able to work around with things. All right, and then again, certification level training would be full day or up to week-long classes when you're going towards a professional level certification. This would be the equivalent of something like a Cisco network professional certification out there. A little bit tougher than like a CCNA, so you want to have probably at least 6 months to a year experience and taken some of the trainings or majority of them before you go for the PCNSC. All right. We can pull more information out of this, guys, but I'm running out of time and I want to make sure that we open this up for everyone else out of here. So first things first, I would like to say thank you for listening to my presentation. Happy to be here and be able to talk to you guys about security. But I would like to open up the floor at this time and open it up for any questions. And I'm also going to pass it up back to our team here at New Horizons and thank them for letting me come talk today.
Thank you so much, Chris. Really appreciate you coming and speaking about Palo Alto networks and training. I want to let everyone know I received a few questions already. We will be sending you all the recording link later today. So in case you want to go back and review anything, you'll be able to do that later today. So you should receive an email from me. Just want to thank you guys for attending our Security Then and Now webinar and hope you've gained some insight into what Palo Alto Networks has to offer through its comprehensive security platform and how training is the key to success. If you log on to our website at newhorizons.com and search Palo Alto training, you'll find all of the training options available. You can also contact your local New Horizons Center. And if you aren't familiar with who your local New Horizons Center is, just go on to newhorizons.com and do a zip code search to find the center nearest you. And Chris, we do have a couple questions that have come through. The first one, is there a good starting point or a guide to follow for learning Palo Alto products?
Yeah, absolutely. I'll actually post a link here. Give me 1 second and I'll post a link. It's paloaltonetworks.csod.com. And it will take you to their LMS system, their learning system. If you create an account, you don't have to be a customer to create an account on here. There are free trainings, and they actually have a training track, and it'll break it out for you. So you'll be able to look at things like next generation firewall professional, or Traps endpoint, or cloud data center. They've got tracks individually for each one of those so that you can kind of specialize and take a look at that stuff. And then you'll see the more professional certifications like the PCNSE on there as well. So let me type that out here real quick. Actually, one second. So can you share that out with them, Kelly?
Let me see.
Okay. I just didn't see an option to send to everyone. I'm sorry.
Yeah, and you know what? I don't have that either. So I'll go ahead and just include it in the email that I send to everyone.
Perfect.
Yeah, later today with the recording. We'll do that.
Right. Absolutely. And then just a side note for other resources, if you're just looking for quick tidbits or kind of want to get or just a rundown on some of the other platforms, check out their YouTube channel. They have a really, really cool whiteboard series that gives quick, 5 to 10 minute introductions. It talks about things that I talked about today, things like decryption, some of their other solutions like Aperture or autofocus. So definitely check that out, kind of play it in the background while you're on the side if you want.
All right, and I think we're going to go ahead and wrap up today's webinar. So again, thank you so much, Chris, for joining us and speaking on behalf of Palo Alto and Cloud Harmonics.
Absolutely. Thank you for having me, Kelly.
And thank you so much, everyone, for joining us. We'll go ahead and wrap up today's session. Hopefully, you guys will be able to join us for the rest of our cybersecurity webinars we have for the rest of the month. So be sure to go to newhorizons.com, click on the webinars link, and you can sign up for any upcoming sessions. Thanks so much, everyone. You may now log off. Have a great day.